Hi guys, we are going to use some properties of congruent triangles today and prove triangles congruent using the definition of congruence. Okay, so to start, we know that geometric figures are congruent if they have the same size and shape. Okay, corresponding angles and corresponding sides have to be in the same positions in polygons, and they have to have an equal number of sides. Okay, so two polygons are congruent if and only if their corresponding sides are congruent. Thus, triangles that are the same size and shape are congruent. Okay, so here is a big table that just lays out the properties of congruent polygons. You can see that triangle ABC is congruent to triangle DEF, and the order matters. So because A and D are both first, here, we'll number them. We'll do them in red. Okay. First, after the little triangle symbol, that means that those vertices are corresponding. Okay, so that means that the measure of angle A is equal to the measure of angle D, that angle A and D are congruent. Okay, look at B and D. Sorry, B and E. Okay, they're both listed second. So that tells us that angle B and E are congruent. Okay, same with angles C and F. They're listed third, so those are corresponding and they have to be congruent. Okay, same thing works with the sides. AB has to be congruent to DE because those are the first two after the triangle. Okay, they have to go in order. The order tells you how they match up. This is just like when we did those mappings for our transformations. The order told you which points from the pre-image corresponded to the points in its image. Same thing. Okay, guys, same thing for this polygon. We don't need to talk about that again. That was probably a lot. We do need to say this. Okay, to name a polygon, we have to write the vertices in consecutive order. For example, for this little polygon here, you can name him PQRS. Okay, starting at P and going around, PQRS, or you can name him QRSP, starting at Q, going around, QRSP, or you can call him SRQP, SRQP, okay? You start at one and go around in either direction, but you can't do crisscross. So look at what you can't do. You can't start at P and then go to R and then go to Q and then go to S. You can't do that. Okay, you have to do a loop. Okay. All right, in a congruent statement, the order of the vertices indicates the corresponding parts. Okay, I think I already tried to say that. Given that triangle PQR is congruent to triangle STW, we have to identify all the pairs of corresponding congruent angles and sides. Okay, this is easy. So, P and S are both written first. Okay, so angle P is congruent to angle S. Next, Q and T are written second. So angle Q has to be congruent to angle T. Okay, third is R and W. So angle R is congruent to angle W. Okay, that takes care of the angles. Let's do the sides. Okay, so the first two are PQ and S2. Okay, so PQ has to be congruent to ST. Okay, notice that I do not write TS. Okay, TS is in backwards order. If the P is first, the S is first. Okay. What else? QR is congruent to TW. TW. Notice that you cannot write WT. Okay, those are backwards. Don't write them in backwards order. You have to go in the same order that they're given to you. Okay, last. RP is congruent to WS. Okay, don't write SW. Has to go in the same order. All right, that's enough of that. All right, you guys will like this one. This is the third angles theorem. If we've got two angles of one triangle congruent to two angles of another triangle, then our third pair of angles are congruent. Well, because they all have to add up to 180, right? Okay, so here you can see that we've got these two congruent and those two are congruent. So our last pair, angle N and angle T, are congruent. Okay, now we have our right angle congruence theorem. This is kind of like a well-duh theorem. We can put this in the well-duh category. All right triangles are congruent. Well, duh. Okay. If A and B are right angles, then they are congruent. Awesome. Let's keep it moving. These famous mathematicians think they're so smart. I could have come up with that one. Thanks for nothing, Euclid. All right. So we've got triangle ABC, and it's supposed to be congruent to triangle DBC. Now, the way that they are named tells us their corresponding parts. So notice that A and D are both first. That tells us that A and D, the angles, are congruent. Okay, notice that B and B, okay, that one and this one, those are next. Those are congruent angles. And C and C. Okay, well, that's these ones. I'm just going to give these both a little right angle thing because all right angles are congruent. Okay. If one of them is 90, the other one has to be 90 also because they're a linear pair and they have to be supplementary. Okay, well, duh. Okay, so let's find x first because we were just talking about those. So x. If this angle is 2x minus 16, and those are both 90 degrees, this one has to be 90 degrees. So we can subtract 16 from 90. Guys, I think it's 74. So 2x is 74. And then if we divide that by 2, I don't feel good. I'm not going to try this one in my head. You're lucky you got 74 out of me. Okay, 74 divided by 2, 37. Oh, I should have. Okay, we got 37 for x. Let's just test that. Oh, no, that's not right. Gosh darn it. I subtracted 16. I should have added 16. Okay, this is why you check your work, guys, because you never know when your brain is going to stop working. You got to add 16 both sides. Okay, so 2x equals, what is that, 106? Yeah. Okay, we got to divide 106 by 2. 53. That makes more sense. Yeah, that's right. That was not right. All right. All right, shake it off. It's fine. It's fine. Okay, so if this little angle A is 49.3, this little angle D down here is also 49.3. Okay, so I've got two 49.3s. That means that I can figure out what the measure is for this big angle by subtracting the two 49.3s from 180. 180 minus 2 times 49.3. I got 81.4 for this guy. 81.4. But I don't want the whole thing. I just want half of him, right? So I'm just going to divide him by 2. And that should give me the measure of angle DBC. I got 40.7. See if that's what Mrs. Madsen got. Oh, yeah, that's what she got. All right. Whew. Now we have to find x and the measure of angle F. All right, well, we can do this. So let's label our angles. So A is congruent to D. Okay, good. I see the little right angles. That makes sense. B is congruent to angle E. And that leaves C and F. Okay. So okay. Let's work on the measure of angle F first. Just because I can't stop looking at this angle right now. If this little angle is 53 degrees, then so is this little angle 53 degrees. Right? Because those are listed as congruent in the way that they're listed. Okay, so I've got 53. I got 90. If I subtract 53 and 90 from 180, I should get the measure of angle F. 180. Did I say? I don't know what I said. I don't know how I turned off my camera, but sorry about that. Okay, so I'm doing 180 minus 90 minus 53. I'm getting 37 for the measure of angle F. Okay, so the measure of angle F was 180 minus 90 minus 53. Okay. All right, now let's talk about X. X. So this little segment here is corresponding to this little segment here. Okay, so 6 has to be equal to 2x minus 2. So 2x minus 2 equals 6. Add 2 to both sides. 2x equals 8. And x is 4. That is also what Mrs. Madsen got. So we're good. Alrighty. You might remember these from Unit 1, or you've totally blocked them out because Unit 1 traumatized you. Either way, you need to know them now again. Okay, so these are some more of our well-duh properties. The first one, reflexive property of congruence. A figure is congruent to itself. For example, the segment AB is congruent to the segment AB. Well, duh. Okay, symmetric property of congruence. The congruent statements are true even if the order is changed, if it's flip-flopped. For example, if angle 1 is congruent to angle 2, then we know that angle 2 is congruent to angle 1. Well, duh. Okay, transitive property of congruence. If we've got two figures congruent and a third figure is congruent to the second figure, then the first and third figures are also congruent. That sounds worse than it is. It's really easy. Let's say that if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle GHI, okay, then we know that our first triangle ABC, ABC is also congruent to our last triangle, triangle GHI. Easy. They're all congruent to each other. All right, let's do a proof because those were so much fun. All right. So we're given a whole bunch of stuff. We know that segment AD bisects segment BE. We know that BE bisects AD right back. Let's label that. AD bisects BE. Boom, boom. BE bisects AD. Boom, 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 boom. Okay, we know that AB is congruent to DE. Okay, that was already on our picture. Ooh, I gotta change these ticks. Okay, these should get 3 and these should get 2 because one tick was already used. Sorry about that. Okay, angle A is congruent to angle D. They already marked that for us, but I'm gonna remark it. Okay, so let's get started. We're gonna start with angle A being congruent to angle D. Let's do that one. We know that angle A is congruent to angle D. And how do we know that? It was given to us. All right, next, we have a pair of angles that we haven't talked about yet that are congruent because of the vertical angles theorem. Okay, that's these two. So I'm going to call that angle ACB congruent to, let me get them in the right order, DCE, angle DCE by the vertical angles theorem. Okay, now let's go and get our third pair of angles congruent. Okay, we've got angle B congruent to angle E by the third angles theorem. Thank you, third angles theorem. All right, next we've got some more given information. So we got to work on the sides. We've got all of our angles congruent. Oh, I didn't tell you this. I'm sick and I don't feel good, so my brain is not working very well. We're trying to prove these triangles congruent. To get the triangles proved congruent, we have to show that all of their angles are congruent and all of their sides are congruent. So we just got all of their angles proved congruent. That was this bit that we just did. We have all angle pairs congruent. Sorry that my brain is everywhere right now. I don't feel great. Okay, so now we have to get the sides And then if we know all of the angles are congruent and all the sides are congruent, we can use the definition of congruent triangles to say these triangles are congruent. Okay, so we got to get the sides. So the first side that we know is congruent is boop, 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 boop. I think it's the A, B, and D, E one. Yeah. All right. So it's this one. This is the one we know already. Segment AB is congruent to segment DE. Okay. The next thing we know is that AD bisects BE. Segment AD bisects BE. Okay, guys, sorry, there was like a little mistake on the notes, which is not at the end of the world, but we're just going to fix it. So we actually have to do 2 chunks, otherwise we're not going to have enough lines. So we have to do AD bisects BE, and we have to do the other one also, that BE bisects AD. Okay, so they are actually bisecting each other, and that actually gives us 2 sides. I was like, wait a minute, we don't have enough lines. Okay, so if AD bisects BE, I know that BC is congruent to EC, and AC is congruent to DC. Okay, and that comes from the definition of a bisector. Now you can see that I have 1 pair of sides, 2 pairs of sides, 3 pairs of sides, all congruent. So I've got all of my angle pairs congruent, all of my side pairs congruent. I can now say that triangle ABC is congruent to triangle DEC by the definition of congruent triangles. All right, cool. Let's do another one. That one was so much fun. Okay, we saved this behemoth for second. So this time we're going to come up with the justifications. So we know that these 2 triangles, triangle YWX and YWZ, are right triangles. YW bisects angle XYZ. XYZ. So those are congruent. And point W is the midpoint of XZ. And we know that XY is congruent to YZ. Okay, these 2 are also congruent. Okay. So how do we know that these 2 angles are right angles? Well, it's given to us. So that's our first justification, given. Okay, how do we know that angle why, shoot, my brain just died. Okay, sorry. These two angles are these two right here, okay? And the reason that we know that those two are congruent is because all right angles are congruent. All right angles are congruent. Okay. Okay, we know that YW bisects angle XYZ because that was given to us. Okay, so if this is bisecting it, then we know that these two are congruent because of the definition of a bisector. All right, let's say angle bisector because we're not talking about a segment. Of an angle bisector. Okay, so that's these two. Oops, that's these two that are congruent. Okay, we know that W is the midpoint of XZ. That was given to us right here. Okay, we know that XW is congruent to WZ because of the definition of midpoint. Whew. Okay, let me zoom out a little bit. Okay, next. Whew. We know that YW, the segment, is congruent to YW, the segment, because of the reflexive property, the well-duh property. Okay, we know that angle X is congruent to angle Z by the third angle theorem. Okay, and then we've got segment XY congruent to segment YZ. That was given to us. Okay, now if you look back over this, we have all of our sides congruent, all three sides and all three angles congruent. So now we can say that these triangles are congruent by the definition of congruent triangles. Okay, one more proof to go. Here, I'm going to leave this on up here for like a second in case you need to see it. Oh, shoot. You can pause it if you need to write it down. Okay, now I'm going to move it. Okay, let's do this one. Okay, we've got these diagonal bars across a gate giving it support. Okay, yeah, we've all seen that. Since the angle measures and the lengths of the corresponding sides are the same, the triangles are congruent, but we are going to have to prove that. So we know that PR and QT bisect each other. So just like on our last proof. So PR bisects QT and QT bisects PR. Okay, we know that angle PQS is congruent to RTS. And segment QP is congruent to segment RT. Okay, I color coded them so I didn't forget which ones were which in the middle of the thing like I did before. Okay, so first we know that we've got some let's start with that little side, those little sides, QP and RT that we just did in orange. We know that QP is congruent to RT. That was given to us. What else was given to us? Those two angles, PQS, angle PQS is congruent to angle RTS. That was given to us. And we know that PR and segment QT bisect each other. Okay, that was given to us. So if they are bisecting each other, we know that QS and TS and PS and RS have to be congruent because of the definition of a bisector. Okay. Oh, look at these ones. Okay, look at this. QSP and TSR. QSP, that's this guy, and TSR is that guy. Guys, those are congruent because of the vertical angles theorem. Okay, so we've got the vertical angles theorem. All right, then our last two angles, which are SRT and SPQ. Those have to be congruent because of the hold on. It's fine. We're good. I just found another mistake. It's fine. Okay. So those are the third angles that have to be congruent. This little guy, 1, 2, 3, and this little guy, 1, 2, 3. That's a hot mess. Sorry. Okay. So finally, we get to the very bottom where our triangles are congruent, and that is because of the definition of congruent triangles. Okay. Guys, that's going to be it. I think we're going to be done for tonight. Yay!